your feet around and we'll see how we get on today. Go on, move them around so you're sitting facing forward. Goodness me. Oh. Make sure that's on silent. So, okay, I wonder, I thought today, if you want to, we could have a look at an article in a magazine that I found was quite interesting. So we can do, hey, give me a hand, give me that hand as well. They don't need to be in your mouth. We could do a little bit of reading and have a chat about the article. Let's just look at the title. So the title's at the top there. What is the article about? And the big title says, in hot water. And then there's a subtitle, abandoned coal mines contain a precious, you keep moving along, resource in the warm water they hold within. Oh. So this article is about what? A, B, A, N, good, A, B, A, N, D, O, N, keep it going, you're doing so well, E, and do the D. Abandoned, this is very nice, your pointing's gone really good today. Abandoned. Abandoned what? C, O, all the way over. What, a bit over? A and L, abandoned coal. Abandoned coal. M, where? I, N, all the way up to the E. E and S. Yes, this feature is all about abandoned coal mines and the precious resource that they contain is W. W, next letter, go on, you're there. A, ooh, R, warm, keep it going. Next word would be W, all the way up. A, T, E, oh yes, the precious resource that they contain is warm water. Okay, so let's just find out some of the facts from this story. Ooh. Oh, sorry, I've got so many pieces of paper. Right, so in the UK, did you know there are 23,000 coal mines which are abandoned? Did you know that? You could just tell me yes or no. What? Yes or no? Y or N? They are, use a pencil. Just tell me yes or no for now. Oh, that was R. N for no. No. No, you didn't know that. I wouldn't have guessed that there were that many coal mines. I didn't even realise there'd ever been that many coal mines, if I'm honest. I found that quite amazing. So, why are they abandoned? They're abandoned basically when they've kind of got the most of the coal out that has been easy to access. So these coal mines lie under the surface, carved into the subsurface. They rest beneath 25% of the country's built environment. So beneath 25% of our built environment. Now I happen to know that when you buy a house, that there's always searches done to see whether the house has been built on top of a mine, because there can be a danger of subsidence. And the very first house that I bought was in a mining area, and we had to have special searches done to make sure that our house wasn't built in a place that it was likely to sink. So let me just show you what a mine looks like. So here's the surface, right? And then let's just say they start digging the mine there. So they go down on the main mine shaft like that, which goes deep, okay? And then there's like sort of tunnels that spread out like that. There would be one. And can you see? So actually these tunnels get nearer to the ground. They don't quite come up to ground level, but they get nearer to the ground the further away from the mine shaft. So if you had a house that was really close to the mine shaft, actually the tunnels underneath would be the greatest distance. Can you see there? There's the mine shaft. Yeah, feel it. And there's the tunnel that goes along. So if you bought a house here, let's just draw a house on it. We're going a little bit off track here, but never mind. Let's just draw a little house there. If you bought a house there, you would have to be careful because the ground underneath isn't as thick, so the ground might sort of begin to subside into that tunnel. So the danger is subsidence. Let's just practice that word. Sub, S, U, up for the B, S, U, B, sid, S, I, D, ence, E, N, C, go for the C, C and E. The danger is subsidence. Yeah. Anyway, so basically, when they've got most of the coal out of these mines, they basically abandon them, and often these mines get filled with water. Now, because the mine shafts are deep, that water gets heated from the Earth's core. Because the deeper you go, the warmer it gets. So let's just draw the Earth and what it looks like. We've got one circle there, that would be the core, and then around the core we have the I think actually we have the inner core and the outer core, and then we have something called the mantle, and then a thinner layer surrounding the mantle is the Earth's crust. And the core is basically like molten lava. careful. There. I didn't know this. I had a little Google. That they think that in the core of of the Earth, the temperature is 7,000 degrees Celsius. That's not even a figure I could imagine. And that is the same temperature as they reckon on the surface of the sun. Goodness me, could you imagine that? Anyway, so this water that fills up the abandoned mines is heated from where? From the where? C-O-R-E. Yes, it's heated from the core. Okay, so really we would call this geothermal energy. Geothermal. Let's just do that word. Geothermal. G-E-O-T-H-E and R and M and A and L. Geothermal energy. Let's do energy. Should we try with the pencil? That might be easier for you today. Energy. Go on. Let's get you using your energy. Geothermal. I'll hold the board a bit lower. Let's see if that helps. E. N. E. That's very good. Go on, touch the R. You're there. R. And the G. G and why? Geothermal energy. Very nice. Okay. So basically, if we've got warm water existing somewhere, this could be a potential energy source for us to make use of for heating things. But the problem is, how do we extract and use and produce geothermal energy to sort of heat homes, provide our energy, etc.? Okay, well, the way that we do it is that there is something called, they're experimenting with something called a mine energy system. Mine energy system. Oh, yeah, you can have some more. There. So this would involve having a piece of equipment on the surface. So we'll draw the surface there, and we'll draw like a box there. There's the exchange, and that would be called a heat exchanger. So the water, the warm water would be pumped up from the mine. It would go through the heat exchanger on the surface, and the heat from the water would be transferred to another liquid. So transferred to another liquid, which could be something like brine. Brine is like salted water, or antifreeze. And then the water is just recirculated back down again to be heated again. Okay, so the mine energy system transfers the heat from the water to another liquid, which could be B-R-I, that's good, N, all the way for the E. It could be brine, or it could be, what was the other one? A, N, go T, I, F. After the F, keep it going, you're doing so well. After the F, R, E, E, down for, right the way down for the Z. Right the way down. Here it is. Touch it. Down. Move your arm down. Yeah, you've got to go down. Look. This is how you touch the Z. There. There. Now you touch Z. Touch it. Z and then back to the E. Yes, it could be brine or antifreeze. So, then they would have to have, if you can imagine, they'd have to have pipes that would run, they'd probably run underground or something with this brine or antifreeze. So then, running through our central heating pipes and through our radiators in our houses, we'd have the brine or the antifreeze. Yeah. Okay. But one of the problems with this system, there's always problems. One of the problems is that actually when the water comes up to the top, it's not really hot enough. So let's just say it's tepid. So it's not really hot enough. Therefore, you would have to have a pump, a kind of a heat pump, to heat it up a little bit more. That would be one option. Another option would be to drill deeper to where the water is hotter. So two options. One would be to have a H, E, go for the A, T, E, oh yes, one would be to have a heater, and that would actually use electricity to actually heat the water, and the other one would be to drill D, you were there, so put to drill D, don't get stuck, always think, I'm going for the next letter now, D, E, very good, and another E, E, go for the P, go on, go for the P, go on, touch it, P, E, and touch the R, touch it, go on, touch it, move your elbow, move that elbow, move it, move your arm, touch the R, go on, touch it, touch the R, R, to drill deeper, yes. Which, again, that can be quite an expensive process. Anyway, listen to this. They've done an experimental project in the UK, in Gateshead, which is in the, if this was the UK, rough math, very rough math of the UK, Gateshead is up in the north east. We're in the Midlands, aren't we? That's Birmingham. Gateshead is in the north east. Touch Gateshead. That's right, yeah, very good. So, they have used this process of having this heat exchanger on the top, and they've used it to heat local warehouses. Let me just see, here we are. Oh, actually, yeah, so in Gateshead, it's a commercial scale project. Geothermal is used to heat warehouses of a wine supplier. It said, we'll read this bit, for a bigger rollout, Heat network infrastructure would be required. Gas boilers in most homes would need to be replaced with heat exchangers and heat pumps. Gosh. Nevertheless, this transition is one the researchers think makes a lot of sense, and it's being debated in Parliament. It says a lot of people don't realise how much water there is in these abandoned mines and how extensive the resource is. So the project to heat the wine warehouses is, where did we say? Where did we say it was? G. Go on. Gateshead. G. Up for the A. A. T. E. S. H. This is nice. For the E. E. A. And D. Very nice. Yeah, that's where the project is, and they're heating the wine houses. So there's a picture there as well, look. Can you see that one? That's an abandoned mine in Cornwall. Look. So if we were able to use this sort of energy, would you call this? Would you say that this would be like a green or a clean energy, or would it be something else? What would it be? G R E E. Go for the N. N. Yeah, it would be a type of what we call green energy. And what does that mean? Green, when we describe something as green energy, what does that mean? N. And P and K, F wouldn't make sense, so let's just go for the N again. N. O, that would make sense. N, O. Come on, next letter. N, O. T, not. Green energy is not. Try, go on. There. Put your foot down flat, get yourself nice and stable instead of leaning on them. Green energy is not, let me just move my chair, get myself in a better position. Is not, where? Q would make sense, not. P. Yes, come on, after the P. O. P, O. Come on, use this. This is good. L, L. U. Not pollute. T. I. Go on, touch the N. Move your arm. Move it. N and G. Green energy is not polluting. Yes. So it would be. It seems silly, doesn't it, to not make use of resources that we've already got in our country, in these coal mines. I hope that was quite an interesting feature. Here we are. Listen to this one. Just to even if they had to have this like heat pump on the surface, they said that for every kilowatt of electricity used to run the pump, around 4 kilowatts of heat would be produced. So although it wouldn't be carbon zero, it's low carbon. Yeah. And if you were to swap a domestic house boiler for a heat pump, you'd probably reduce the carbon emissions by around 75%. So that would be a good thing. So apparently they're doing that project in Gateshead, and around the world there are now 30 sites globally which currently use heat from mines. So I think that's a good thing, isn't it? I think I did a little Google, let me have a look. Oh yes, and of course in Iceland they've got one that is using sort of really the heat. They've got more sort of volcanoes there, so they're using volcanic heat. So that would be another free source really of energy for us. So just to finish, Iceland uses VOL C, come on, after the C, A, N, after the N, O. Yeah, Iceland uses heat from volcanoes.